Hello, here's my follow-up video. I wanted to walk through a specific example where we could see how I store data and what happens at each iteration. So we'll start with current size equal 3, and we finish through size of 2. And on the right, I have my matrix, which was like a randomized set of values. And I ran my code and printed out all the data before and after each iteration for reference and made it out here for this. So at this point, we would have iterated all the way through size 1 and 2, and the values will be updated to hold the values from previous sums necessary for us to calculate the sum at this point. And I highlighted the colors for the data that was actually updated. The darker outer edges never end up being used again. And that is one interesting thing I thought it would be interesting to visualize. So to make things look neater, let k equal I plus current size minus 1 and w equal j plus current size minus 1. And this is how we would calculate outer edges. So for the sum, I would first grab the bottom right corner, which is my matrix, kw, and I highlighted it here in the table in the top. Sorry about that. And then I would also add the rows value at k and j, which starts at 0, 0 and goes down 3. And the value here will be the sum from the previous spot where this was added with, these two were added together to get 10 here. And that's what the value here right now. And then same for columns, we start at 0 and go right 3. And that is the sum of 4 and 8 up here. And then we get the previous sums, which is right at I and j. And what I noticed when creating this diagram is that you could just think of it as 4 corners. We get one corner from my matrix, another corner from previous sums, then one from rows and columns. And so right now we're just doing the math for sum. And then once we do that, it's sum equals 43 in this case. We will write that back into previous sums. And as you see on the right, I update the values here. And then previous sums, it will be sum 43. For rows and columns, we will add the bottom right corner from my matrix. So it's 10 plus 1 and 12 plus 1. So these spots are just added by 1 from this value right here. And if sum were to be equal to v at this point, we would end here. Otherwise, we would move on to the next iteration where j equals 1. And in each array, the old value for the previous spot will now be ready to accommodate the next size. So we could potentially already do size of 4, I equals 0, j equals 0. But we can't make use of anything else just yet. And then, okay. So we do the same thing, except everything is shifted to the right. Because we're starting at I equals 0 and 1, which is right here. So for my matrix, we go down 3 or down 2 and right 2 to get to the bottom right corner. And then previous sums is now here. And the rows is also shifted to the right in the columns. So we grab the values from each of these 4 corners and add it together to find the sum. In this case, the sum will be 42. So we update previous sums with that. And then we add the bottom right corner from my matrix, which is 7, to the rows and columns at their individual spots. So at this point, we've gone through 2 iterations. So it'll keep shifting to the right, updating these values. And then once it reaches the end, which would be j equals 2, it would go back to 0, and then we'd have I equals 1 instead. So it would start down here. And then I think I'll also submit my code with the extra for loops to print it out if you'd like to see for yourself how it works. If you have any other questions, you can DM me and ask, and I'll try my best to answer them. Thank you.